Good morning, students. This is Max class. I hope all you are safe by God's grace. Yesterday, we learned that imaginary unit. How to find out that imaginary unit, the value of I power n, isn't it? We have did one exercise using that. Today, we are entering into the complex number. Say the definition 2.1 rectangular form of a complex number. A complex number is of the form x plus iy. This is the form of a complex number x plus iy or x plus yi. Iy or yi both are same. Where x and y are real numbers. X and y are real numbers and x is called the real part and y is called the imaginary part of the complex number. So complex number will be of the form x plus iy. So normally we will denote it as z. Z is equal to x plus iy. So x is called the real part. So real part of z is equal to x. Since it is near to I, that is imaginary part, Im of z is equal to y. Okay. For example, if z is equal to 2 plus 3i, this is a complex number. So for this, real part of z is equal to 2. Then imaginary part of z is equal to 3. Is that clear? Or else z is equal to 5 minus 4i. So here, real part of z is equal to 5. Imaginary part of z is equal to, normally this is of the form x plus iy, isn't it? Here minus is there, so we have to take the minus together along with the coefficient of I. Is that clear? This is called the rectangular form, or normally a complex number is of the form z is equal to x plus iy. Some problems will be given, they will ask us to find out, write it in rectangular form. Write it in rectangular form means we have to make the number in the form x plus iy. So x and y should be real numbers. X and y will be real numbers. So real part of z is x and along with I, the coefficient of I is the imaginary part. Is that clear? Then when we can say the two complex numbers as equal, see definition 2.2. Two complex numbers z1 x1 plus iy1 and z2 x2 plus iy2 are said to be equal if and only if real part of z1 is equal to real part of z2. Real part of z1 is x1, am I right? And real part of z2 is x2. So x1 must be equal to x2. And imaginary part of z1 is equal to imaginary part of z2. That is y1 is equal to y2. That's why that is x1 equal to x2 and y1 equal to y2. If both are same, then we can say the given two complex numbers are equal. Actually that is, see, and z2 also must be equal to 3 plus 4i. So 3 is equal to 3 and 4 is equal to 4. Then we can say the two complex numbers are z1 is equal to z2. Is that clear? Now, organed plane. The complex number, when we mark it in the graph, we will give that as organed plane. Okay, when we mark it in the graph. That's the organed plane. That is, a complex number z is equal to x plus iy is uniquely determined by an ordered pair of real numbers x comma y. So z is equal to x plus iy is equivalent to x comma y. Say for example, the numbers see this, the numbers, three numbers are there. This one is equivalent to 3 comma minus 8. 6, there is no imaginary part. So it is understood this is 6 plus 0 I. So I can write it as 6 comma 0. And this is minus 4i. There is no real part. This is actually equal to 0 comma 4 minus 4i. So this, when we write it in as x comma y, we may get it 0 comma minus 4. Is that clear? See, when organed plane, this is actually x and this is y, isn't it? So in complex number, this is a real part and here it is imaginary part. Real part and imaginary part. X plus iy. Actually somewhere here it will be there, x comma y. This is complex number as a point. Suppose with the position means joining us from 0 to that point. That is position vector pointing from the origin to the point. Pointing from the origin to the point. That's when we join. Here it is real part and this is imaginary part. And it is from 0 to some x comma y. Or even you can write it x plus iy. This is from position to the point. Okay. If you are writing it as a vector, this we can call it as a point when we join two points. For example, say 2 plus I minus 1 plus 2i. These 2 points we can take it. 2 plus I is equivalent to 2 comma 1. Minus 1 plus 2i is equivalent to minus 1 comma 2. So this we can take it a real part and this is imaginary part. 2 comma 1. So 0, 1, 2, 3, minus 1, minus 2, 3. Here also we can take 1, 2, 3, minus 2, minus 3. Our ordinary graph, in place of x comma y, we have written real part and imaginary part. 2 comma 1. So 2 plus I minus 1 comma 2 somewhere here. That's minus 1 plus 2i. When we join these two, we will say it as vector. Is that clear? This is what? Organ diagram. So these all little basic things, and now we should learn how to add, how to subtract, how to multiply. Shall we move to that? Algebraic operations on complex number. First one is scalar multiplication. See, if z is equal to x plus iy and k belongs to R, any real number, then k into z, our ordinary multiplication, k into x plus k into y, I. Or if it is 2 into z, that is 2x plus 2y into I, or 2x plus I into 2y. Both are same. Just our ordinary multiplication. Now the second one is addition of complex numbers. Z1 x1 plus I1 and Z2 is equal to x2 plus IY2, where all the coefficients x1, x2, y1 and y2 belongs to the real number R. Then Z1 plus Z2 is equal to, say, x1 plus IY1 plus x2 plus IY2 is equal to. We should add only the real part as well as imaginary part separately. So here when we add, that is x1 plus x2 plus I into y1 plus y2. x1 plus x2 plus I into y1 plus y2. Is that clear? If you want an example, 3 plus 4i plus 2 plus I is equal to, we have to add this, that is 3 plus 2 plus I into, here 4 and here the coefficient is 1, 4 plus 1 equal to 5 plus I into 5. Is that clear how we have added? Do you understood? Now shall we move to the next part? Subtraction of complex number. The same way, subtraction z1 minus z2 means x1 plus iy1 minus x2 plus I into y2. So x1 plus iy1, this minus if we give inside, minus x2 minus I into y2. If we separate the real part, that is x1 minus x2 plus I into y1 minus y2. This also we can draw in the organ diagram and check it. Okay. Now the fourth one is multiplication. Multiplication of complex number, that is z1 into z2 is equal to x1 plus iy1 into x2 plus I into y2. Okay. See, ordinary multiplication only. Our answer will be of the form x1 x2 minus y1 y2 plus I into x1 y2 plus x2 y1. x1 x2 plus minus y1 y2 plus I into x1 y2 plus x2 y1. It's don't think that it's a formula you should learn. No need. You just check it. We can do it with the number 3 plus 4i into 2 plus I. The same number I have taken. This. See, ordinary multiplication. First multiply with 2. 3 into 2, 6. Plus 4 into 2, 12i. Now 3 into I plus 3i. Plus into plus plus. 4i into I is 4i square. We know that the value of I square is equal to minus 1. Isn't it? I equal to root of minus 1, I square is minus 1. So we may get 6 plus 12i plus 3i. This is I square, that's minus 1. So we may get minus 4. So 6 minus 4, 2 plus 12i plus 3i is 15i. Exactly this ordinary multiplication only. See, x1, x2. 3 into 2, 6, isn't it? Minus y1, y2, minus 4 into 1 is minus 4. See, that answer only we got here. Plus I into x1, y2, x1, y2, that is 3. Then x2, y1, 2 into 4, 8. Isn't it? x1, y2 plus x2 y1. When we multiply, we have got it 12i plus 3i, that is 4 into 2. Actually this is not 12i, this is 8. 8i. 8i plus 3i, that is 11i. Yeah, there's a mistake. See, 4 into 2 is 8i. 8i and this 3 into 1, that's 3i. 8i plus 3i is 11i. Is that clear? How to multiply the numbers? No need to learn this formula. Actually, when we multiply a complex number, again we will get a complex number. Note, multiplication of a complex number z by I. See, if z is equal to x plus iy, iz, multiply by I into x plus iy. This is ix plus I into I square into y. We know that I square is equal to minus 1. So, we may get ix minus y. So, if I write first the real part, we will get minus y plus I into x. Minus y plus I into x. So, see, when we draw the graph, this is real part and here it is imaginary part, z, x, comma, y, that both are positive, isn't it? So, we may get somewhere here, that is z. This is I into Z, isn't it? Here the real part is negative. So when we take a point, negative and positive. Somewhere here. This is I into Z. Don't consider it as x comma minus y. Always real part comma imaginary part. So real part when we draw, this is the line. Here the negative point we will get it. And here this is positive. The same way I square, when you multiply you may get the point somewhere here, that is I square into Z. Here I cube into Z. Same. For all the changes there will be a 90-degree variation will be there. The complex number Iz is a rotation of Z by 90 degree. In radian if we say, that is pi by 2 radian. Pi by 2 radian in counterclockwise. Counterclockwise, that is anti-clockwise. Okay, clockwise means this is the direction, isn't it? When we multiply Z by Iz, if Z is in first quadrant, when we multiply by Iz, we will get the answer in second quadrant. Suppose if Z is in the second quadrant, when we multiply by Iz, we will get the answer in third quadrant. Or if it is in third quadrant, we will get the answer in fourth quadrant. We have the one word. The complex number (90° or pi by 2 radians. If you want, you can use any number. Z is equal to 2 plus 3i or 4 plus 5i. Take it and check it. You will be getting, this is the way. Okay. If Z is in the second quadrant, Iz will be in third quadrant. Is that clear? Do you understand? Shall we move to the problems? Simple problems. Exercise 2.2. First one, evaluate the following if Z is equal to 5 minus 2i and w is equal to minus 1 plus 3i. So first subdivision is Z plus w. Say Z plus w. Z is 5 minus 2i plus w, that is minus 1 plus 3i. We know that when we add, what we should do? Real part separately, imaginary part separately. So here we may get 5 minus 1 plus I into, here the imaginary part is minus 2 plus here the imaginary part is 3. So 5 minus 1, 4 plus minus 2 plus 3, that is 1. So 4 plus I is the answer. Is that clear? Second subdivision, Z minus IW, which is equal to 5 minus 2i minus I into minus 1 plus 3i. Just we have substituted the values. Now we should simplify. 5 minus 2i multiply with minus I, minus into minus plus I into 1 is I. Minus into plus minus I into 3i is 3i square. We know that value of I square is equal to minus 1. Say 5 minus 2i plus I, that is minus I. Minus 3 into I square, the value is minus 1. So 5 minus I, minus into minus plus 3. So 5 plus 3, 8 minus I. This we have brought it into the complex form. Then the next subdivision is 2z plus 3w. See 2z plus 3w is equal to 2 into, substitute the value of z, that is 5 minus 2i plus 3 into w, the value of w is minus 1 plus 3i. So we may get, that is, first we should multiply, isn't it? 10 minus 4i minus 3 plus 9i. So now 10 minus 3, 7. Minus 4i plus 9i, that is plus 5i. So we should simplify the real part separate and imaginary part separate. That's all. Now we have 3 more subdivisions, that is Z into W. This is multiplication. See Z 5 minus 2i into W minus 1 plus 3i. Our ordinary subtraction. Shall we multiply? See 5 into minus 1 minus 5. This minus into minus plus 2i into 1 is 2i. Now 5 into 3i, that is plus 15. 5 into 3 is 15. Minus into plus minus 2 into 3 6. I into I square. This is minus 5 plus 2i plus 15i is 17i. Minus 6 into the value of I square, we know that is minus 1. So minus 5 plus 17i plus 6. See now minus 5 plus 6, that is 1. 1 plus 17i. Do you understand? Almost we have did everything. Now the fifth part is Z square plus 2ZW plus W square. So ZW, we can substitute this answer. But before that, what are the things we need? What is Z square and what is W square? Say Z square plus 2ZW plus W square. See, Z square plus 2ZW plus W square. Either we can find out Z square, W square, ZW already we have found out. Substitute and add it. Or it's just a C. This is A square plus 2AB plus B square, isn't it? So even we can write it as A plus B the whole square. Already we got it. Z plus W in the first subdivision, that is 4 plus I. So directly I can substitute, that is 4 plus I the whole square. See, this like matrix, we cannot square as it is, isn't it? A square means we will be doing A into A. Here also we have to write separately and do it. A into A, here it is 4 plus I into 4 plus I. Shall we simplify? See 4 into 4, 16 plus 4i. Again plus 4i plus I into I is I square. So this is 16 plus 8i. I square the value is minus 1. So 16 minus 1, 15 plus 8i. Is that clear? See the next subdivision they have asked Z plus W the whole square. This also I am writing the same 4 plus I the whole square. This no need to do it again and again, isn't it? Directly I am writing that is 15 plus 8i, because in the previous subdivision only we have did this. Now problem number 2. Given the complex number Z is equal to 2 plus 3i. Represent the complex number in organed diagram. This we have to mark it in the organed diagram. Subdivision 1 Z, IZ, Z plus IZ. So first we will find out all the values. Then we will draw in the organed diagram. Z is equal to 2 plus 3i. So we need next IZ. IZ means I into 2 plus 3i. What we may get it, Masi? 2i plus 3i square. But I square value we know it, isn't it? So 2i, I square is minus 1. So we will be getting minus 3. Or this is minus 3 plus 2i. So this is 1 and this is 2. Then Z plus IZ. Z is 2 plus 3i plus IZ is minus 3 plus 2i. Add it ma, 2 minus 3, that is minus 1, plus 3i plus 2i, that is plus 5i. This is 3. This 3 we have to mark it in the organed diagram. So we can put, this is real part we know and this is imaginary part. Okay, the first one is 2 plus 3 means 2 comma 3, isn't it? So somewhere here this is Z. The next one is minus 3 plus 2i. So minus 3 comma 2. So minus 3 comma 2. This is IZ. We know that if Z is in the first quadrant, IZ will be in the second quadrant, isn't it? Then Z plus IZ, the third one, minus 1 comma 5. Somewhere here this is Z plus IZ. Isn't it? Just we can join it. Yeah, we have got a triangle. The same way, subdivision 2, Z comma minus IZ and Z minus IZ. Same way Z, we know Z is equal to 2 plus 3i minus I into Z. So minus IZ value we know that is minus 3 plus 2i. So this will become 3 minus 2i. Then Z minus IZ. Z is 2 plus 3i minus IZ. IZ value I am substituting, okay? Minus 3 plus 2i. Or 2 plus 3i minus into minus plus 3 minus into plus minus 2i. 2 plus 3 that is 5. 3i minus 2i that is plus I. So for this is 1, 2 and 3. These 3 answers we have to mark it in the organ. So 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, 1, 2, 3, 4, minus 1, minus 2, minus 3. The first one is 2 comma 3. So this is Z. Minus IZ 3 comma minus 2. IZ means it will be in the second quadrant, isn't it? Since it is minus IZ, it has come to the fourth quadrant. Now Z minus IZ 5 comma 1. 5 comma 1, that is Z minus IZ. Is that clear? See, one more part is there in this exercise, that is regarding equal complex numbers. If two complex numbers are equal, find x and y. That is the question. So that we will continue in the next class. Okay? Just go through it. If you have got doubt, please ask me in the interactive session. Thank you, students. See you in the next class. Bye-bye.